in question 5, we've got to work out some combined matrices. So in the first part, it wants us to do a reflection of the line y equals x and then a stretch. So there's a couple of ways to do this. One way is to write the two matrices. So first matrix, we want the reflection in the line y equals x. So that line there. So let's see. So the point 1, 0 would go to 0, 1. So that's the first column of our matrix. And the point 0, 1 would go to 1, 0. So that's the second column of our matrix. Then we want a stretch parallel to the y-axis, scale factor 5. So the point 1, 0 won't move, but the point 0, 1 would go to 0, 5 because it's going to go 5 times higher. I then want to combine those matrices. So the order, if you want to combine them, is to do second matrix times first matrix. So 1, 0, 0, 5, 0, 1, 1, 0. And then we just multiply those together. 1 times 0, 0 times 1. And that's our combined matrix. The other way is to get that directly by thinking about where the points 1, 0 and 0, 1 goes. So the point 1, 0 gets reflected in the line y equals x and then gets stretched by the stretch scale factor 5. So overall, the point 1, 0 goes to 0, 5. What happens to the other point? Well, the point 0, 1 goes on to the point 1, 0, but then it's not affected by the stretch because that's parallel to the y-axis and it's on the x-axis, so that stays where it is at 1, 0. And as you can see, that matches our final matrix. So part B, we want a reflection in the line y equals 0. So the line y equals 0 is the x-axis. So our first transformation is that the point 1, 0 is going to go nowhere, it's reflected in the x-axis, and the point 0, 1 will get reflected to 0, minus 1. Now our second matrix is rotation. The handy thing with rotations is it's in the formula book, so you don't have to think about it. So we can just look it up in the formula book, as if by magic. Right, so this should now be cos 30 degrees minus sine 30 degrees, sine 30 degrees, cos 30 degrees. That's our transformation. We would then be expected to put those in an exact form. Okay. So either by memory or by using your calculator. Okay. Cos 30 is root 3 over 2. So that's those two. And sine 30 degrees is a half. Okay. Now we've got our two matrices. Remember, it's second times first. Okay. And you can check it in a similar way to before by thinking about where the points are going to go. The other way you can check it is by working out the matrices and doing the multiplication in your calculator, although it won't give you this third form, which is why we need to do it by hand. Right, why could this not describe a single rotation? Quite a standard exam style question. Well, here's the matrix for a rotation. So as we can see, it doesn't match. So we need to say something about rotation matrices are of the form. Now we have cos theta, cos theta. So you can either say cos theta, or we just call it letter A, and then B, and the important thing being that it's minus B. So if it was a rotation, the change of sign should be on that diagonal, but it's not. Okay, so this matrix has the negative sign on the wrong diagonal. Bear in mind that you could have, for example, it doesn't have to be in the top right. You could actually have your negative sign in there. The important thing is the two numbers on this diagonal here have opposite signs, not what we've got here.